Venus dwarfed by the Sun as it passes across its face in 2004, an event witnessed only 6 times since 1639. On June the 5th and 6th, the transit of Venus occurs again, to the delight of astronomers worldwide. It's the last chance they'll get to see the celestial event. The transit occurs in 2 stages 8 years apart. There won't be another for more than a century. Dr. Marek Kukula, public astronomer at London's Royal Observatory in Greenwich, says skywatchers are in for a treat.
This animation shows you how the transit of Venus occurs and what people here on Earth can expect to see. So Venus is moving between the Earth and the Sun, and when it does that, people on the surface of the Earth will see Venus as a tiny black dot silhouetted against the Sun. So they'll get a view something like this, with this tiny black dot, which is the planet Venus, moving across the face of the Sun. And it takes Venus several hours to cross from one side to another.
Getting a decent view of the transit, in reality, depends on your location.
The best places are in Asia and around the Pacific, where you should be able to see all of the transit. People in North America should see the beginning of the transit just before the Sun sets, and people in Europe will get a chance to see the end of the transit just as the Sun is rising on June the 6th. It's only people in Western Africa and South America who won't be able to see any of it because it happens at night when the Sun is on the other side of the Earth.
The transits of the 18th and 19th century were crucial to understanding the size of the solar system. Astronomer Edmund Halley, for whom a comet was famously named, was the first to correctly forecast when the transits would occur. But knowing he'd be dead when the transit appeared in June 1761, Halley encouraged his successors to collaborate. It heralded the beginning of the era of international scientific collaboration, according to Royal Observatory curator Dr. Rebecca Higgett.
You get some maritime expeditions being sent across to other parts of the world as far apart as they could. And very famously for Britain in 1769, that was the voyage led by Captain James Cook, who went to Tahiti to observe the transit in 1769. One of the instruments behind me is something that was built for 1874, a photoheliograph telescope, and they made 5 of those by the same maker so that they could all be essentially exactly the same. You're sending people to other parts of the world, but you want them to be able to produce results that can be compared with each other.
21st century technology will open the next transit to a wider audience than ever before, although for many it'll be far more than an entertaining diversion.
There are also scientific rationale for observing as well. One of them is in relation to the black drop effect, which was first observed in the 18th century, and is still not entirely understood as to what's causing that, whether it's to do with the Earth's atmosphere, the Sun's atmosphere, an optical illusion and so on. So there's still a number of questions there.
In 2004, the Royal Observatory saw hundreds of visitors watching the transit through telescopes or special eclipse glasses. Staring at the Sun with unprotected eyes can cause serious damage. The pyramids in Cairo served as another backdrop for a host of amateur astronomers, all of whom are polishing their glasses and preparing their telescopes for the second stage of this once-in-a-lifetime event. Jim Drury, Reuters.